this. And browser. Alright, so what we're gonna do, actually, you know what I could do while we're doing this, let's see here. I hope it doesn't show up. We could just back this up. Oh, wait, just cut and pick a minute here. So, I'm gonna just play some of this music here while I'm... If I can just get this thing up here. I'm gonna go over what this Raudive Diode is whilst I am in the midst of eating something. If I can get over to my... This is a basic setup right here. Actually, you can't see it in the video thing here. So we've got the browser in the background. That's the basic setup right there. So what I'm going to do is I'm going to build that setup in this simulator. I'm going to see how far I can get with it while I'm munching out on a meal. That looks like a coil. I wonder... I'm just wondering if I can put something up into the front here. Like, probably can't, can I? Oh. I guess I did. 10K and a 2000 picofarad. I have to eat. Wait just a second. Where am I? No, I can't have that on there right now. Chihuahua. I'm trying to do half a dozen things at once. Now we'll connect these together with wait, where's my browser? Why didn't I keep this? See, the browser will... Oops. That's my music. The browser will show up in front of the simulator, the way the broadcaster works. Why would they show a picture of a diode like that? Chihuahua. I just have to go back and flip my music back here. This here we'll put maybe a generator. Actually, it would. I wonder if I can grab everything. Let's see. No, it won't let me. Well, I could do this. Let's see. Move this over. Wow. Not quite what I envisioned for that to happen. Now there's actually what I want to do. Let's try something. Oh, my stream's acting up over here for some reason. There's something else that I want to do. See, there's an LED here. Let me just. I want to see something here. No, I shouldn't be. I should know this. Make this a 2K. the small side is your ground. And my music stopped here again. I don't want it to. And then this goes to ground. Well, that doesn't work very well. I don't really need a ground. So I've got a 2K resistor, an LED, and I want to add, maybe I can just use this, and we'll just try this multimeter. So I'm looking at the voltage on this, that's 12 volts. Probably should make that like 5 volts or something. Let's try 6. Well, it takes it a while for this to light up. If it lights up at all, it might blow up. The meter's not even up. I gotta put a ground in. The reason why I'm putting this LED in is because it's a diode. I don't know if it's germanium or silicon, but it doesn't matter. I got some ideas on some things. I don't know if I should have a 1N34A diode kicking around somewhere. Alright, there's my meter. So the resistance across this thing is 1.6 volts. I think it takes 1.3 volts to light the thing. God, I gotta get more food, I'm hungry. The music's almost done. Somebody else sent me a message. Yeah, good luck tomorrow. I am just live streaming, actually, on the internet, if you want to watch. But I'm sure you need to get some sleep. Oh, don't play that music. It should not. Oh, you know what? It shouldn't go into the autoplay. Okay, that's shut off. It doesn't show if this thing is lit up or not. Display. 1.6 volts. Let me try something else here. I'll make this 9 volts. And the 2K is in there to limit the current. Alright, it's still reading. It's still reading 1.66 volts, but it doesn't show, like, does this thing light up or something? I don't know. If I go to we'll look up LED diode, light emitting diode, blah blah. Semiconductor die, wire bond, blah blah blah. Cathode. So that's pretty good. I can drop this web page right across my. Oh, that thing is still simulating. Huh? Thing here. Silicon carbide. Crystal. I'm just kind of wondering what they put in there. Like, so germanium gives a voltage drop of 3 volts, or 0.3 volts. The silicon diodes give off a voltage drop of 0.7. This thing's reading 1.6. I don't know what they're using for material. Ultraviolet LEDs, gallium nitride. The reason why I'm looking this up is I'm wondering if there might be a chance to use different kinds of diodes in place of the 1N34. It's just kind of interesting thought. Anyway, let's go back and let's see, file, open. Uh-oh, that's not good. You know what it did? It kept saving. I don't want automatic save. Yeah, I don't know, there's a bunch of stuff going on. Alright, well, let's just get rid of this. Crap. We have to have a ground to make the circuit. I need another capacitor here. So we're going to simulate this Raudive circuit here. This is a 10K. Let's put this over here. This guy over here. Need a diode. Let's put the diode here. And according to other circuitry, that goes to an amplifier like audio. So we could just hook a scope up to that. Just hook up a scope to that, I think. We will use our illustrious Agilent oscilloscope, and we'll just plug in channel 1 right to, oops, to there. Our ground, no, actually, oh, there is a ground here. What's this C text? Now over here we need an antenna, or we can use this type of noise simulator. And there actually might be something in here that simulates noise. That'd be pretty cool. Gotta go grab some more. I gotta get some more food. I'll be right back. Maybe, maybe not. It's so cold in here. So I'm just cooking up some food. Yeah, let's bring this back. Google Astral Nirvana on YouTube. I am working on my electronics projects and live streaming them. It should be interesting tonight. I specify this diode. Display label. No, I can't. Just Google what I told you and you'll find me. It says live or whatever. Oh, what am I gonna do? I gotta name this diode and I don't know how to do it. Symbol editor, component wizard. This is weird. Magnetic core in there. I don't know how to... Oh, what is this? A virtual diode. Let's try this one. Get our music back here. Huh. I just want to load a model. Replace. I don't think a diode's in the list. Obsolete? Are you kidding me? I got a selenium rectifier too. I don't know if I could use part of that in the circuit. That'd be pretty cool. I gotta have more music. Music, music. I'm just trying to find out if it's silicon or germanium or what it is. I should know this stuff. I'll tell you what, let's see. I'm still working away on some food here, so I am. There's a circuit we can use to test our diodes. Well, I don't know. I don't know if that other one's in that list. I'll try this one here. Database access denied. Oh, lovely. Well, there is a database problem. I already knew that, but I'm going to explain to you what this little circuit is here momentarily. If I can get it connected. Now I'll run this to... I can never connect anything to ground here. The music's getting a little monotonous. Alright, so this is a basic. Now I need probably another. Maybe I could use a capacitor in here. Maybe. And I need another generator somewhere. I'll use 1 kilohertz. Now the white noise source, I'm going to put. Oh wait just a second, this is not right. This has to go here. And this white noise source connects to here. This connects to ground. And channel 2. So what I'm doing, I'm going to remove this. Is this circuit's not going to do anything, these resistor and capacitor. It's just going to sit there. What I'm doing is I'm mixing a white noise source. This is going to be millivolts, and this is going to be I don't know what the value is. So we're mixing a white noise source with this 1 kilohertz signal here into this FET. I don't know if I should provide a feedback loop. There's a 1K there, 10K there. This is my output. This is the mixed output, and the input. I'm gonna change this to the white noise source. I have to have a ground. There's my ground. Let's see if it explodes. Oh, what's wrong with my stream here? Something's wrong with my streams. I'm not watching the stream. There we go. That's a little odd. Turn on our scope here. So I got a DC value on there. I'm looking for the coupling, and I'm not seeing it. See, it's using DC coupling. Channel select. Well, isn't that peculiar, huh? I don't know. Oh, here we go. AC. I don't know why that's going up in the air like that. Ground. Why is ground going up in the air like that? X, Y. I don't know. It's acting a little strange. Let's try something else. I wanted to mix those two signals together. And my stream is having issues. Or being able to monitor it is having issues. I'm going to go back to the original thing here. We could assume, let's see, actually, I think, let me, wait, 100 value, this is 100 millivolts. Change that to a volt. 1 kilohertz. Magnitude. Signal voltage. Thought there was a way I. Oh, I know what it was now. I know what it was. We want a function generator. In the circuit, but it's not connected. Oh, let's see. Let's try something. We connect the white noise source to there, and that, and we will just look at that output and see if that gives me anything. My stream is having an issue over here. I have to keep refreshing it. That's YouTube. It does that. You have to refresh the video. Alright, let's see if we can pick up the noise source. Yeah, it's still doing its funky chicken here. It might be something to do with the noise source simulation or something, I don't know. Let's do this guy. We'll just put in a sine wave. 1000 hertz. Actually, well, let's put in let's put in 1 megahertz sine wave, and then let's see, this is the plus, that's the minus, that's a common. Now I'm just looking at this filter setup, and then we're gonna put the diode in there, type of thing. I gotta look for those diodes. I got a bunch of them. And I gotta build an amplifier. Yep. Alright, so we definitely have a voltage there. That's 2 volts. That's at 1 megahertz. That's 4 divisions at 1 megahertz. So actually what we're doing is we're going to check the bandpass of this thing. That's why I was wondering, I was hoping I could have, wait, I can't, can I change this on the fly? Yeah, I don't think I can. Wait, you wait a minute. I got a better idea. There's an Agilent function generator we can use. And see what that looks like. So we've got one output here. And that even has noise. Wait, I have to have that inside the window, don't I? Maybe you can put the generator over here somewhere. Again, this takes a few minutes to load. I'll turn this on. That's 1 kilohertz. I don't know how to change this to megahertz. Wait, oh. Wait a minute. Kilohertz. Oh, wait a minute. Oh, there we go. Well, actually, that doesn't do any good either, does it? Oh. megahertz. Oh, that worked. Hmm. My amplitude. 1 volt peak to peak. I see a line, but I don't see anything on there. Oh, there it is. See, that's the delay in the circuit for the circuit to get started. So what I gotta do, I'm gonna move that somehow, somewhere. Just you're gonna do it. How do I move that bugger over there? Acquire display. Display. Can't move that over. Well, we can see the level. That's really all I'm concerned about. Let's change this frequency. Oops. Amplitude, frequency. 1 megahertz. Now what just happened there? It takes a little bit to process the signal. I can see the signal coming through. Uh-oh. Yeah, I can see the signal there, so that's taking 10 kilohertz. There's 1 kilohertz. Oh, I didn't close that door out there. I guess it's taking 1 kilohertz, but I don't see the change. This is probably just better for me to set this up on the breadboard, because this is just not working out very well. Let me stop the simulation. Now what we're going to do, I'll delete this, and we will put in a virtual diode. I'm a little bit disappointed here because I want to see, we can sort of see on the end here what's happening. But when you put an AC signal into a diode, what that does is it clips like this. It's going to half-wave rectify the diode. See how the signal kind of goes up and down on the top and the bottom? So when we hook a signal up to this, basically all it's going to happen is just going to rectify this. Meaning, yep, meaning it changes it from AC to DC type of thing. I want to build this circuit up on my breadboard. And I might put it in the frying pan. Toast it up. I forgot the database wasn't working. Okay, it's doing something here. Is that... It's kind of going across the whole screen. It's 1 kilohertz. Oh, there's actually a signal in there. Wait. Yeah, see? You can barely see it. I don't know why I can't get access to... how do I get this? Oh, there's that display. Let's see. Acquire, utility, display, acquire. Quick print, save, recall, cursor. Cursor? Where is... Huh. Well, this is just not working out the way I want. Anyway, you can see there's a spike up there. A very narrow, let's like halfway rectified. Let's chunk the frequency up here. 10 kilohertz. I mean, it's still there, but it doesn't look as good. 100 kilohertz. Because we're using a virtual diode. I'm going to have to run this on the breadboard. That's all there is to it. This is not working. The simulation business is messed up. So let me just X right out of it altogether. No. Let's look at this Raudive Diode thing. So this is on iDigital Medium. There's a lot of stuff here. That's sort of the basic circuit. I need an amplifier. I don't know why that showed up. Video capture device. I need browser. So there's some other ideas here about how to build this thing. Now that diode's in a different direction, or is it? No. Yeah, I guess it is. Middle A, doubling the frequency in terms of musical, 440 hertz. Ideas for a paraphysical component may be found in abundant literature, blah blah blah. Magic of sound. T had success circuit 3 with circuit 2 is all Bluetooth. T uses a commercial two-stage valve amplifier for shared aerials to which a diode is coupled. As a transformer, that's like an audio transformer thing. This is sort of the same circuit. It's got the capacitor on the other side of the diode. It's like variations of this circuit. Basically, this is like a crystal radio. That's all this is. That's all this is. It's a crystal radio. I don't even know why I'm doing this, to be honest. It's ridiculous. Here's the itcbridge.com picture. Somebody is working on ideas. Same pictures. Same pictures. Same pictures. No, this is all set up right on a little input thing to your computer. I have... That's interesting. I have a USB. The keyboard is... Okay, the keyboard, a mouse, headphones, and the camera. I don't think I have... There's not another slot in there for... I'd have to hook up something else. I mean, if I took the camera off, we can build a circuit. Oh, I don't know if I got the driver for that other thing or not. I have no idea. I thought there was some other pictures of this thing. Good EVPs. Raudive Diode device in depth, 2013. ITC voices. I don't know what that is. Viagra. I guess they got hacked. I don't know. What they're using. Oh, there's images. Let me go to images and see what we got here. There's a coil. Shielded cable to mic input. Look at this one here. The Raudive Diode receiver modernized. It's got different coils, different... Well, I wouldn't classify that as a coil. That's more like an antenna. There's a earbuds. Oh, there's earbuds. I've got some earbuds, and they got it connected to that. And the Raudive Diode thingy, and then this thingy. We'll get there. They got this in a copper shielded thingy. Oh, the pain, Dr. Smith. You know what this looks like? That looks like those telephone coils. I have those. Oh my God. $80? Are you kidding me? And it looks exactly like this other guy's building things. Are you serious? God, I had to go into business. Seriously, I could sell these for cheap. $80. Microphone voices. Recording the white noise from a Radeon no tuned to the ghost box was born, blah blah. Diode voices recording from a crystal set not tuned to a station. Here you have it, the Raudive germanium diode mic. Wow. Call a crystal radio a Raudive diode and sell it. Are you kidding me? That's really sad. Seriously. What is this? Raudive Diode assembly. Oh, 20% off on this one. Ghost Supplies EVPs. Oh, there's 2 customer reviews. Ooh. Currently unavailable. This is really great. I have great results with it. It won't help you see dead people, but it helps you chat to them. Loud enough to wake the dead. And this one says 5 stars. And this one 1 star. A real fraud. Only the external sound can record with some static. Waste of money. Electronic necromancy does not exist. Oh, what people don't know. It's just strange. We gotta really start. Now this is a different one. A simple radio receiver. See the difference here. It's got a capacitor, a diode, resistor, capacitor, another capacitor there. This is exactly a very similar circuit right here. Now see this picture here. This is like a mixing circuit. That's what I was trying to build. 3819. That's the FET that I got actually right there. 1 megohms. This is a antenna input connector. It's a little amplifier. It's DC up here. The only problem with this circuit is when you build a circuit like this and you have this resistor is 1 megohm. Well, the resistor itself creates a lot of noise, which is probably useful in EVP circuits. And this was actually the preamp, or this is a preamp idea for building such device as I was talking about. This is 2.2 nanofarads. No, I don't know what that is. We had a chart up here, didn't we? See if we can find the chart here. Two nanofarads. Actually, it's 2,000 picofarads. 1,000 picofarads is 1 nanofarad. So 2 nanofarads, or 0.001 microfarads, is your, so 0.002 microfarads would be 2,000 picofarads. Where am I? Now this circuit I could build this. I wish we had. I'm going to run that circuit again. It won't take long to come up. Alright, so that's up. We're gonna build this circuit. If I could load up. Let's see. File, open, Raudive, open. Cut. So 2,000 picofarads. This is a 10K. We'll change this to 470 ohms. No. What? 470K. Okay. And then we've got instruments. We're going to use function generator. There's got to be a sweeps thing on here. There's a sweep right there. If I can figure out how to use that, that would be nice. Because that's really what we need to do. And we've got another capacitor. Copy. Paste. And this value is 220 nanofarads. And there's a diode in there. Let's put that in, I guess. There's a diode. And there's a 1 microfarad capacitor on the output. Okay. Now we'll put our scope up. What is this? There's an analysis thing here. AC analysis. Noise figure and noise analysis. I don't know what that does. I don't know what I did. Probably broke it. Frequency parameters, input noise, source, change filter, output node, reference node, simulate, frequency parameters. Ooh, 1 hertz to 1 gigahertz. I don't know how to do this. So we're going to use, oh, maybe no wonder I didn't get the, wait, this is a scope. So I gotta put this guy over here. This guy goes over here. Generator, I can't even get in there. Alright, so the generator, here to here, and a scope. We're going to look at the input from the generator and the output here. That should work. Let's see, file, save. Now how does that compare with the actual other Raudive Diode thingy? We've got a diode on top of a resistor and a capacitor, and the output goes from that junction. It's basically the same thing, except we've got the addition of 2 capacitors here, and the reason for that is to block DC voltages and simulate this thing. While it's getting ready, I'm gonna grab some things here as in a snack. So, I am here to both support claims and debunk claims at the same time. So this is similar to a Raudive Diode circuit. But when you look at the circuit, the only difference is, like, I wonder if let's look up, I'll tell you what, let's do this. Here's a crystal radio. Now, if you look at the crystal radio, you've got your earphones, you've got your capacitor, you've got your diode, you've got a coil in here. That's sort of like an antenna type thing. Well, actually, no, it's not. You've got a variable capacitor and a coil. And you can see the coil set up here in these pictures. And like this coil moves in and out and such. This is a very elaborate type of a coil system, which is, now that I think of it, it's actually really interesting. But what that does, it creates a tuned circuit, which the coil, it's called an LC tuned circuit, and that will tune various frequencies, which are called carriers. And what you have riding on those carriers are your radio stations, including this one. diode in this case is your detector thingy, like this guy here. They're just using a diode rather than a detector. These are pretty cool. Just think, if we have no electricity or whatever, you could build something like this, and you with your basic stuff. That uses, there's a crystal radio right here with the 1N34 diode. But it's got the tune circuit versus our Raudive diode does not use that. It uses a non-tune circuit. It's picking up everything. And so let's turn this stuff on here. Oops. It's not moving. It's a little slow. I want to keep things in a picture, but I can't do everything here. Because what we're doing is we're looking at both the input and the output with these two capacitors. There's no tuned coil. I want to try to do a frequency sweep. Let's see if I can. Simulation error. So you got 1 volt peak to peak AC. If I do shift sweep, if I go frequency, now it's sweeping, but I'm guessing maybe, I don't know if that's the high end. Did something happen over there because I wasn't paying attention? Wait, I'm looking. At the input. Oh, that's distorted. Well, there's a spike in there. See, the diode we're using is not. I can't. I know it's not changing the frequency or something. I don't know. I think I really just gotta set this up and do this. on the board because this is just taking too long. You know what I mean, burn? I'm gonna find some diodes. Now I will drop the browser and bring up the camera. Uh-oh. We could probably use these capacitors. I need a 1 microfarad. I gotta hook up my... I gotta plug everything in. Get some stuff turned on, type of thing, as it were. See if I can blow something up tonight. No! We don't blow things up. Fucking... I knew it was gonna happen. Once. Am I missing something? We'll find out soon enough. Let's see what we got turned on here. I need to find an LM386 and get a speaker over here somewhere. Now I don't know what's wrong with this guy over here. So there might, I don't know if there's a 386 in that pile. Oh, I got a speaker. These are what? Those are all timers. There's a chip over here doing something. It's another timer. And another timer. Take this stuff out. This is a connector over there. Op-amp circuits. I wonder if there's a 386 in here. A 386 is a amplifier for your speaker. We need to have that. There should be one in here somewhere. Well, they're using they get a 2N222. That's 9 volts to ground. Let's compare our circuits. Stable flip-flop. Clipper. There's the 386. There's one there. There's another one there. So that uses a 10K for the input, 220 microfarad. That's a different one. I'm just wanting to see the different circuits for this. But I gotta find a 386 somewhere. Those are timers. Audio mixer. Resistor 741. 9 volts. I don't want to use. Wait a minute. Oh, the pain, Dr. Smith. I wonder if I got a 386 in this little box here. That's probably a 741. Dual timer. Another timer. TLO 71. That's a 741. There's a 386. 741. Maybe we could use them both. Oh, these guys like to hang out together. TLO 71 is another op amp. I have a lot of 7041s. TLO 82. I've got a capacitor there. A variable capacitor. I got a coil down here, which I can't use. And I might have, if we could be so lucky, that might be a 1N. I'll have to do a voltage measurement on that guy and find out what it is. I'm not sure what value that is. A couple of them. I don't know what this one is. Alright. Now they're using a 10K resistor These are 1Ks. And a 220 microfarad out of the 386 on that one. This one has a 100 microfarad capacitor. So we could probably use 100 microfarad. 10K resistor, 100K. Nothing's actually going on over there. Let me see if I got some other components kicking around somewhere. What do we got? Do we need a 100K capacitor? What is this guy? I don't know what that is. It's probably a 20%. 0.002 microfarad. Ooh, now that's the 2000 picofarad right there, I think. Let's see what we've got here. Got a bit of a mess. I don't know what's connected to what here. I need to disconnect something though. So this might be the capacitor we're looking for. I wonder if I can put this stand up here. Now that's reading 3 nanofarads. It says 3 nanofarads. So if we go to our illustrious chart, which you can't see over here. Let's see, where's my chart? 3 nanofarads. 1 nanofarad is... Wait a minute, where's that circuit again? Raudive Diode is 2000 picofarads. So 1000 picofarads is 1 nanofarads. So I've got a 3000 picofarad capacitor. It's a little bit higher in capacitance, but I think it'll work for our intents and purposes. So we'll throw that one in there. What else we got kicking around here? What is this creature? It's a resistor of some sort. Odd. This is a 50 microfarad. Just hook this up here. I mean, we were sort of looking for 100 microfarad. I think there's a couple in there. We could combine these if we had to. These aren't electrolytic though. So that says, well, I don't know what it's reading here. It's overloading. We may have to go into that box. interesting to use a non-electrolytic I think this one's an electrolytic. 0.22. Get your crap in here. I really should get into that other box. This is being a pain in the ass tonight. Oh, there's something down there. This one. I can't even read the numbers. 470 microfarads, which is a little high. Let's just see what my meter reads here. Oh no, it's not reading. It's not reading the microfarads for some reason. It could be because it takes a while for the battery to charge or something. I don't know. I don't know. Now I got a bunch of these guys in here. I wonder what this is. I have no idea what this is. Find out soon enough. Well, that's reading 10 nanofarads right off the bat. What is that? So that would be 10 nanofarads is 0.01 microfarads. That's a 1 microfarad. And we have to have a 470k resistor. We gotta have a bunch of stuff here. Yeah, I'm not gonna find it in that mess. That's for sure. I don't know what that diode is. I've got some voltage sources. We could split the voltage source. Doesn't have to be regulated. This thing is my royal pain in the ass, yeah. What do we got up here? Let's see. I'm wondering if there's a higher value resistor in this box that I can use. Oh yeah, there's a 10k there. That's good. Wish I had a bigger resistor for that though. There's a 10 microfarad. That is a magnet. I want that magnet. They seem to be very strong. Huh. That's strange. And lo and behold, we have a 100 microfarad capacitor. Now, in this box, there are tons of diodes. We need a 220 nanofarad. Oh, I don't remember. this is or not. $104K. What's this? 104. 104 nanofarads. Oh, we need 220 nanofarads, don't we? So all I have to do is have 2 of those in series, I believe. Now we just need a 470K resistor. I don't remember my color chart. It's a yellow, something purple. Red, purple. Oh, God, I can't remember. I can't remember. Neon bulbs, guitar picks. What that is. We got some diodes here. Let's see if we can find anything useful. 1N47. 1N4735. That's a rectifier diode. Let's see if we can pull some of this stuff up out of there. That's a glass diode. It's a blue one here. Another glass diode. Some of these guys might be Zeners. That blue one might be a Zener. Zener diode cuts off at a certain voltage. It's like a little regulator thing. This is a 1N4742. Well, I'm not going to use that. Let's see what we got over here. There's a bunch of those. Those are rectifier diodes. Got an interesting looking red one there, which even has a number on it. I'd have to have a microscope to look at this one. Damn, what did I do? Wipe it off? Might be a 1N4148 or something. I don't know. It's another one of these. So I see. I don't know what that one is. It's probably a rectifier. There's a rectifier in there. Capacitors. And let's see. Takes care of that. 4.7's got a purple color on the resistor. Kind of hard to see anything here. Let's see here. That's not it. It's got purple on it. See, that one might be a 370. If it has yellow on it. What's this here? I could use a couple of 220s. Let's see if the capacitor is lower. Resistance could be higher. I'm thinking in terms of that circuit. That's a... well, 464 ohms. How did I get that messed up? Yeah, it's brown on the end. I think I need purple. Shit. I'm gonna lose everything here. Gotta get this out of there. No, I know this is a magnet. Oh, that's not a magnet, that's a ferrite core. It's magnetized though. I have two different round magnets, I think. It doesn't seem to be... I don't know. Where am I gonna put these little guys? Well, I don't know what to do with them. Just put them over here, I guess. I don't really want them attaching to each other. We'll find something here sooner or later. What's that one there? That one might be... oh, it's purple orange. Crap, I should look up the colors, what I should do. Maybe either 22 or 200 or something. Let's see what this one is. Boy. What a life. That's a 2K. That's a 2K resistor. See what this guy is here. That's a 23K. Well, that's not helping me very much. It's got to be yellow on the end. And I'm not seeing anything. Oh, here's something. Let's see, is that... Those are low values. God, why is this so hard to find anything? Is that one? It's a 4.7K, I think. I need like 500K, 470K. That's a 4.7. So what I need... So I got the yellow... orange, and then I need yellow, orange, and yellow or something. I may have to go to the other box and find something. Just not finding what I want. I got 100K. I can't find anything in this box. This is a royal pain. Wait, I know what I do want though. What is this? Why can't I read this? There's a 50K resistor. Here. Which will hopefully stay in one piece. Wouldn't you? But I really can't see very good here. Here we go. So we got a 50K variable resistor there. That'll work. And this guy is something. Ooh, what do we got here? Get another resistor. Nice linear pot. I don't know what its value is. I guess we're gonna have to find out. So to measure the value on these resistors, you just look at the end resistance of the end pieces, and it's not reading. Why? What the hell is wrong with this now? Are you kidding me? Right, something's wrong. I had a problem with the meter. I have a problem with this connector. Well, I don't know, something's wrong with this. Maybe it's opened up or something. I have no idea. Fuck. Let me see this other one. My eyesight is gone. I can't see anything. Alright, that's 47K on the ends. Let's see if we can just go ahead and check the middle one, I guess. So that's set to about 20K, huh? I don't know, that other one's not working. Something's wrong with it. Let's look at this one here. The old standbys. That's 27K. Check a 20K resistor or something. Something like that. There's another little speaker in here, which is broke. You think I'd be able to find the resistors, wouldn't you? Such is life. Oh, what's this? Here's a wire wound resistor. 1500 ohms. I wonder if that's got an inductance. Or I guess I wouldn't be able to measure that with that. 1500 ohms. I'm wondering if there's a coil in here. There's another one. Here's the audio transformer. I can't mess with that tonight. I wish I could find something. I can't find anything in here. What's this? It's just one of those nights. Just keep stacking stuff up here. Am I gonna dig deep? Gotta dig deep for stuff. Gotta dig deep. Yep. There's some diodes in there. That's... is it a 1K? Okay, that's a 470. I can't see nothing. I've got... see, I used to work on projects before. So I pulled out a lot of resistors. Let's see what these guys are. I think those are 1K. Those are 10 ohms or something. We will get there. Okay, let's put this maybe right there. Go into my resistor box, hopefully, somewhere. Still nobody watching. That's a 1K. 2K. Neon bulbs. I know I have those resistors. No, that might be them down there. Okay, this might be them right here. So we're looking for 470K. Now that might be, this might be the guys right here. Actually, now what I'm doing is building up the crystal radio, but now that I think of it, the Raudive Diode uses a different, more common diode. Alright, so this is a 40, that's 48. Let's see what this is here. It's 48.3. They're reading a little bit high. There's a 47. So we'll grab number 2. So there's that, and the Raudive Diode, I think he had a 10K in there. Well, let's see what we got here. Raudive Diodes, germanium. That's a 10K resistor. That should be easy to find. I don't want to look in there. I know I got a 10K resistor somewhere. I forget what it looks like though. God. 10K. It's orange or something. Those are 1Ks. Brown, black, orange, brown, black, yellow. I should not have a problem finding that somewhere. Actually, you know what I want to do? I want to put this up here because I'm getting some strain, as it were. I've lost something. I'm losing my mind. You'd think I'd be able to find... Okay, that I think might be a 10K right there. I'm not 100% sure. Black is... or brown is 1, black is 0. That's 100K. So... I'll just leave that out. What was that? Yellow, so I probably need orange for the 10K. Brown, black, orange is what I'm looking for. And there's one right there. And we'll measure that just to make sure. Alright, that's a 10K. So, and another thing, actually now that I think of it, in the discussion of noise, if you use a very high valued resistor, it will create, you'll get more noise across the circuit. It will generate more noise. I'm wondering if we've got a very large valued resistor in here. In the megohms. I saw some, no that, no. So orange is 1,000, yellow is 10,000, or red is 1,000, orange is 10,000, yellow is 100,000. Now there's one with a blue. Now that might be what we're looking for, because we're going to do noise tests also. Oh, that's a 10 megohm. Alright, good, excellent. So that would be, that's a blue. I wonder if we've got a, I don't know if there's a 1 megohm in this mess. I mean, I probably won't find a 1 megohms. There's blue. Blue's 10 megohm. Orange, yellow. Oh, it could be green. Ooh. What's green? I got a green one in here. Right there. If we're lucky, maybe this will be a 1 megohm. And it is. It's a 1 meg. Alright, so very nice. Now there's another There's another coil. There's some coils in here. I wonder if I should throw those magnets in there because I'm not really using them right now. Just get them out of the way. We still got to build up the other amplifier. So we'll do. Let's do the LM386 on the end. And now I've got a 10K resistor. Where did I see a 10K resistor? Is that? It's 470. Might be this orange one. I almost lost it. Oh my god. Alright, there's a 10K resistor, and I'm wondering if I run like this is our voltage. We'll use, see, is it plus minus? How did I do that? Oh, that's from my capacitor. So we need to have one of these guys. It's all crazy. Why the? This stuff should be taped down over here, and it's not. Tape it down. Let me try to fix something here. It's just that I have a setup back here that I want to try to I probably need to do these separately. Maybe I can do them at the same time. No, I did not want to do what I'm doing. Shit. If I can just... What? Oh, I see what I did. What do I have? That should work. Alright, so this will be our ground. Well, I'm gonna have to cut that, I guess. You have to understand that in the process of what I'm doing, I have to make adjustments on the way because nothing's like quite set up the way I want. So things will get better as time goes on when I work on setting up these circuits and everything. Now I got the wrong wire. You know what, I'm just gonna pull all this out of there because it's really pissing me off here. These wires are too long, they need to be cut and I can't get them in the frickin' board. They got a curl on the end of them. You know what? That's negative, isn't it? I got the wrong wire. I need positive, so I gotta cut these. These are just too long. So the black and the brown are pretty much the same. They're actually positive and negative connected together on two batteries. That's okay. Alright, so we've got our positive and negative set up there. And what I want to do, this is a 10K. I just run a 10K. That limits the current through the diode. Let's grab a diode. I want to grab our rectifier diode first. We'll just grab this guy here. It's a little bit heavier duty. Now I can test the diode with a diode function, or I can test it using my resistor. So it reads open in that position there. Now it's giving me a weird reading. I don't know what it's doing. Let's try something else here. There is a diode function. Oh, you know what it's doing? It's measuring the voltage across the diode. So it's giving me 0.7 volts. So that's a silicon. This is a silicon. So what we can do is we could use our meter, because we know the meter's safer than this other circuit that I'm building to test diodes with. So we're going to go through and check out all these diodes. So we're looking for a diode that registers 0.3. Ooh, we found one. Alright, so that's germanium. So we'll put the germaniums up there. Now it does make a difference which way you measure this, I think. That's a forward voltage, so that's just 0.3. It's actually a little lower. So I'm going to do it the other way. Yeah, it says open. So if we put the positive end on, if we put the negative end towards the ground side, it reads 0.3. So put the negative end towards the ground side. That's just point there. They're reading 0.23, kind of a lower value. That one says 0.3 exactly. So where the brown side would be, that would be the flat side of the schematic. That's a 0.7. So this is a silicon. We have a glass silicon diode. There's another 0.3. Well, I like this diode function on here. That's nice. Now I don't know what this blue diode is. That reads 0.6. That's a silicon. And this guy, I don't know what this is. That's reading open. That's 0.5, so that goes in that pile. So we've got a number of germanium diodes that we can try. And we've got those components. Now all we need to do is build the amplifier. We have a 100K capacitor right here. Just set up my thing is a little messed up here. Alright. Alright, and let's see. That's negative and that's positive. Get our 386 somewhere. I think there's only one of them. So hopefully we don't blow it up. That's a 741. That's a 386. Alright, we'll put this over here on the end somewhere. Um, 6 volts. I don't know if the 386 will run on 6 volts or not. I wonder if it does. Let's go look it up. Five to 18 volts, wide supply voltage range. Oh, there's some other circuits there. There's an audio amp for the 386. This has got some extra stuff going on. There's that's connected. Those inputs are connected to ground. They're also using 100 microfarad to the supply, another 10 microfarad for a bypass. That's 10 microfarad from 1 to 8. You get a 10 microfarad from 1 to 8. That's an amplifier with a gain of 200. Uh, 1 to 8. 4 is ground. 8 is gain. 1 is gain. 10 microfarads from 1 to 8. So we could put that in there. 220. So we need another 100 microfarad. Or 10 microfarad. That's a bypass. We need two 10 microfarads and another 100 microfarad. Now we can get those easy because I have some other boxes down here. Over here. Whatever. Not that one. And that's got transistors in it. Oh my god, where the hell is my capacitor box? There's another one down there. Oh my god. Those are various amplifiers, transistors in there. So we're looking for this is 25 microfarad. We need a couple of 10s. That's a 22. So we're not just building the diode circuit, we're building an amplifier circuit so we can all hear this with the speaker setup and everything. There's a 10 microfarad. 10. There's 100. So you get a couple of 100 microfarads, a couple of 10s. What else? There's a 10 ohm and a 47 something. 10 ohm, 47 nanofarads, 100 nanofarads. I want to build a better amplifier than what the other little book says. There's a 1K resistor for the input. This one is a variable input. Using a 10K. 100 ohm, 10 picofarad. I'm not sure what that's. Probably to help bypass something. Let's see. Here they're using 10 picofarads and 100 ohms. Here they're using 10 ohms. Let's use 10 picofarad. Let's see. 10 picofarad. 0.01, 0.0001, 0.01, 10 picofarads. How am I going to find that now? I don't think those are in there. That's going to be a winner. I've got capacitors elsewhere. If I lose my shit back here, I'm going to be pissed, and that's exactly what's fucking happening. I don't know what the hell happened back here. This box, there's something wrong with it. If I lose all that shit, I'll be fucking pissed. I don't know what's wrong. Damn it. I got too much shit here. It doesn't feel right. Where is my other box here? Well, I got a bunch of stuff in there which we're not using. These are not capacitors. I had a bunch of capacitors somewhere. I don't know where they went. Jeez, I think it might be in that other box. Here's the box I'm looking for. So we're looking for like a 10 picofarad somewhere, which is probably one of these small guys, and I'm not going to be able to measure that. Shit. Oh, you know, that's actually those little variable capacitors. There might be a 5.6 picofarad. I don't want that. 20? There's a 20 picofarad. Maybe. I mean, some of the circuits don't even use that, so. 0.5 nanofarads. Let's see what that is. 560 picofarads. Wow. That's 560 picofarads? 223. It's maybe a 220 or 22 times 1,000. Here's something here. $330. Huh. Well, I don't know what this is, but we'll find out, I guess. Oh, jeez. It just flew over there. We're not gonna have good luck finding what I'm looking for, I don't think. Oh, there's tantalum capacitors which are shiny. Those are probably a higher value. It's probably like a .001 or something. There's these little dinky guys here. It's a 103, probably the same thing. There's got to be a small one in here somewhere. What's this here? 0.02. I'm just curious what this big one is. Just 0.02. It can't be any good. $270. Eight nanofarads. God, what is 0.8? 820 picofarads, and I'm supposed to have like a 20. Maybe we'll just put that in there. I don't know. I had a smaller one. It's not gonna work. There's gotta be something in here. I can't read that fucking thing. No, this is a 102K. It's probably like 100 or something. 102, that's be like 100 peak something. This is 1.6 nanofarads. This is 1.5 nanofarads. That's like 1,000 picofarads. Damn. Now, I gotta see what this green one is. That's 16 nanofarads, so those are bigger. I'm not gonna find what I'm looking for. You have to use those little trimmers. Nanofarads. That's a 560 picofarad. That's the smallest I'm gonna get right there. And then we used, let's see, got a 10 ohm. I'm looking at these circuits, you can't see them. Well, actually, you probably could. That's a 10 ohm and a 47 nanofarads. there's 100 nanofarad. I just picked up a 500. I'd have to have two of them things, wouldn't I? I don't know where they get these small capacitor values. Well, that's 0.8. I can put this in with the power supply. Okay. You gotta get to building here. Because it's probably getting late. Alright, so the book in here, this book uses less stuff for an amp. It's got 100 microfarad and the speaker to ground, 6 and 4. 4 is to ground, 3 is to ground. They're using positive as the input on that. And positive is the input on that with a 1K resistor. There's a 10K. This guy is a 50K. And we're using that in the preamp circuit. This is like 27. So I have to use this one for the input. So we'll run that to ground. And we'll put this on the end here. I could almost put that in there if I wanted to. And then run some wires over. See, it goes to ground and the output of the op amp. The center tap goes to 2. 2 is up here. This one goes to ground, and I will just good, just fall down there, you bitch. My wires are just not long enough. This one goes to ground. I have to run a wire from there to the output. We've got the speaker. Which has tons of wire here. So this is going to be ground. This will be, the speaker goes to the capacitor, which goes to the output of the 386. That's 100 microfarads, and I'm going to use this one. Actually, let's use this one. Now, the minus is there, and the minus goes to the speaker, the plus goes to the amplifier. I did some. Oh, the speaker's right there. So that's pin 5 is the plus. 1, 2. I think it's. Wait. Does it show the layout? Doesn't show the layout. Oh, pin 1 is down here on the bottom. 1, 2, 3, 4. So pin 1 is on the bottom. So pin 2 is here. pin 5 is here. That's the plus. That goes over here somewhere. And our other speaker lead goes to here. I'm just hooking this up from here for now. Negative goes to ground. That's pin 3. And then I will optimize the circuit once I get this built. 2 is the center tap. I got the center tap. That's ground. This is the output of the 741. 6 is the supply. 4 goes to ground. So what we're doing right now is we are building a amplifier for the speaker using a 386 op amp. So we got 4 to ground, 3 to ground, 5 goes to the speaker. Speaker goes to ground. That's ground. And that completes that part of the circuit. And the other one just has a capacitor. It uses a 200 microfarad. 4 to ground. Now here it has the minus is pin 2. Uh-oh. They've got this wrong. They've got 2 different pin designations for pin 7, pin 6. What the hell? This is all wrong here. This book, something's wrong in the book. See, this is why we have to check things out. I don't know why that's not showing up in let's see here, it says pin 2 is negative. Pin 2 is a negative input. So those numbers are wrong over here. And the plus sign is pin 3, pin 3. So I don't have a pen to freaking adjust it to change this. Yes, I do. Alright, so these numbers are incorrect. So this is supposed to be pin 2 and 3. I got that changed. That's 2 and 3. Okay, that's correct. Now the voltage is 6. Voltage is 6. Oh, I was looking at something else. Oh, I was looking at the 741. Well, I still had it 2, 3, 2, 3. They still made a mistake here. You know, 2 is minus, 3 is plus. Two is minus, 3 is plus. This is pin 6, pin 4, pin 5. Alright, I gotta check my circuit again because we want the center tap on pin 3, not on pin 2. And we've got 2 going to ground. So that's been corrected. Alright, so now that's the 3, and then we've got a variable we've got that input. And let's see, what do we got? We want to optimize this now. So we're going to put a 10 between pins 1 and 8. And 1 is the plus side. So between pins 1 and 8. That's pin 1 and 8's over there. Well, I assume that's minus. It's showing that as minus. So that's the minus side. So the plus side connects to pin 1, which is over here. That goes to pin 8. So we've got our amplification capacitor in there. Now I've got to find a 10 ohm resistor. That would be back in our yellow box. I gotta scooch down to find this thing. That shouldn't be too hard to find. There's 100K. Do I have 100K out here? It's a 10K. I don't see 100K sitting there. I see 100K here. Throw that in there. So we're looking for a 10K, a 10 ohm, and I believe that's 10 ohm. I've lost everything now, haven't I? That's 100 ohms. Ugh, and I lost it. Shit. I need a 10 ohm. Actually, you know, why don't we use 100 ohm, because I don't want to load the output down that much. We'll use 100. So we run the output. We'll use this little capacitor. Let's see, this one. Oh god, I don't think I can even use this other one. We'll try it here. Wait, that's the input. The output's pin 5. Because there's the speaker. Actually, it's in there. Well, we can... I don't know if it's in there or not. I can't tell. I mean, it acts like it is, but... I don't think it's in there. this other pin is so long. Let's see if I can. Yeah, I don't think it's in there. Well, I don't know. There's that. And what did I do with this guy? So this guy goes from here to ground. Now if I measure from this point to this point, come on, I get 100 ohms. If I measure from there to there, I get 0.5 mega ohms. So it's possible that it's reading across that. Otherwise it would be open if it didn't. Okay. And what we can test that. Well, we don't really. Well, we could test it, I guess. So I got that. I'm supposed to have the other little one is going to go from the power supply to ground. And let's see, the power supply to ground. Let's just do it this way. And I want to measure, it would be nice if I could measure voltage and keep an eye on my voltage. I do have another meter that we could probably wrap some wire around to monitor the DC voltage of our circuit. Let's see, what have I got here? Could probably do like that type of deal. I'm going to strip these wires the old-fashioned way. Well, maybe I won't. These wires are... Some of the telephone wires strip easier, and some of them just do not like me. Just being a royal pain. So I get more wire stripping to do here. That one was easy. So what I'm doing is I get another meter and I'm going to monitor my voltage. Let's see, so we go, this would be plus. Like so. And this is the meter. This tape is trying to, so you can't really see it that well, but that's the meter there. And I will turn this on, and we will wrap this wire around the probe. It's not the best way to do things, but it will work. And let's see, we want this on voltage, 20 volts. Come mess with me tonight. I'm losing everything. I want this meter out of the way so I can see things. I want this over here. This over here. And everything just does not want to stay where I put it. Because I got so much crap here. It's still not reading the voltage. Oh god, I'm losing everything. Ay, Chihuahua! Don't do this shit to me. Why am I not getting a reading? There it is, 6.5 volts. I could tape this down. I guess I'm gonna have to. This thing's pissing me off tonight. I lost my diodes that were up on the top of the box for my 0.3 value diodes. They fell off the box here. I don't know what the hell is what. Now I've got to do the test all over again. See, that's a 0.3. I think these are all 0.3. But I just want to make sure. I'm pretty sure that one was. I should check it again anyway. That's a 0.3. 0.3. There's a 0.3. See, that one got mixed up. I'm pretty sure these other ones are 0.6. It's a 0.6. I ought to put these in a different spot so they don't get mixed up, but I don't really have a lot of room here. That's 0.5. That's 0.5. That one's 0.5. Alright, so I got my diodes separated. We have all of that. We are going to need an op amp because we're going to be measuring lower level signals. So, with that in mind, summing amplifier, single supply amplifier. I'm going to use a dual supply 741. I don't know if the 741s can use 6 volts, I would think. audio amplifier. Transconductance. Silicon solar cell. Non-inverting. No, I want minus. Okay, that's good. Oh, it's a transimpedance. Okay, that uses negative input. Okay, good. So we'll build this little audio amp circuit. We gotta have. I got the variable. I just need a couple of 1Ks and a 1 microfarad. And for that, we go to the yellow box again, don't we? So we need a 1K. Hopefully this will stay put here. No, that's probably a 1K, but that's a big resistor. I want a smaller one. 10K. That's a 1K, I believe. Shit. They're soldered together. That should be actually. Yeah, that should be a 1. What's this one? It's a 50, 560 or something. Okay, the audio transformers are nice because they block DC and such. You see a 1K, but it's a large resistor, and I don't want to use a large resistor. No, actually, there's those 1500 wire round. There's a 1K. Why do I keep picking that? I want to say a bad word. You know what's interesting? I got a couple of 1500 ohm resistors here. These are carbon resistors. I don't think they're wire round. What is this one? That's a 2. I think I found another. Either a 10 or a 1 meg ohm. Yeah, we'll find a 1K in there somewhere. So that's a 10K. There's. Can't use that. I got a bunch of resistors that are like tied together for some reason. There's one right there. And we'll check these out. And I need a 1K capacitor. Where's my capacitor box? That isn't it, is it? I wonder if I can find one in there. Let's see what we got here. I do check. Do you see my comment? Oh, huh? Hi. I do now. I don't know if she probably left. That was probably like ages ago. Do you see my comment? I went to bed about 2 hours ago. What are you gonna do, you know? You get busy with shit like this, it's like, oh, there's somebody there. There's a 0.1 microfarad. That could come in handy. she probably left. We need a 1 microfarad in this mess. Oh, there's a 5. We could play with that. It's just enough to block any DC voltage from getting into the the amplifier stage. That's 100 microfarads. Let's take these big guys out of there. I don't know what that is. Some weird value. There's a 4.7 microfarads. I don't know why I pulled that out of there. Because I'm a retard. That's 100 microfarad. I'm not going to find a 1 microfarad. There's no way. 0.1. We have to use that 4.7. That's a 30. Yeah, I'm just going to use, there's one more here. What is this pretty little blue one here? I don't know what. 10 microfarad. We use the other one. It'll work. Let's make sure we know what these values are. Oh, that's 1K. Yeah, is that what I want? A couple of 1Ks, right? Alright, so we got the two 1Ks. And so now we're going to grab a 741. I want to grab... I'll use this one. Alright. So we've got another variable resistor to stick in there, which is this guy. And the center tap goes to pin 2. Now this is called the preamp. One end goes to the input of that, which is over here. And that goes to ground. Which is here. Now the other problem, you know, we're working with, it's got wires and stuff up here. There's always this chance for interference, but in a way it's okay because we're looking for, you know, these spirits could interfere with any of the interactions of the circuit, and it may find something useful. There we go. Alright, so we've got that connected. Let's see, that's pin 2. Let's see, pin 6. Wait a minute, I did something wrong. This connects to pin 6. I guess there's a wire that goes to pin 6. I have to cut up more wire. I don't want to use that brown one. There's a blue one. Pin 6 goes to there, and it's not long enough. Well, that's gonna mean I need more wire. I'll just use this for some signal wire here. I flip my cadoodle if the spirits start talking. I get all this thing hooked up. Like, hey, what's going on down there? Alright, pin 6 goes to the end value over there. So we just grab this, get in there, and we go to pin 6 over here. 1, 2, 3, 4, 5, 6. There's that. Try to keep wires, you know, not physically touching each other to prevent some cross feed. That's a dual supply, so we're going to need the other battery over here. We will use, this will be our negative. I'll put that here. And we can cross connect the ground. Means I gotta strip another wire. Once we get into the intricacies of low voltage, I have another scope over here which is unable to be seen by the camera that goes into a lower value of voltage, but we will have an amplifier set up with filtering, and like here, this piece of equipment which seems to be blocking the view is a resistant, like a attenuator type thing, which we could put in there somewhere. I'm having a problem with this frequency meter, so I'm just going to shut that one off. Alright, so we've got minus, and we've got ground, so I need to tie our grounds together. And just remember that minus supply goes to, and I should check my minus voltage. And I'm not getting anything. That's not good. Well, I'm not getting anything because that's our minus. That should be my minus supply. I don't have a reading. Alright, I'm gonna have to pull this off of here. This I got 6.65. heck is killing me tonight here? I don't know why I don't have a reading on this. This is my other wire. Just check here. I'm not getting a voltage reading. Oh, I know. That's... No, I'm not getting a reading. I got a reading across there. I'm not getting a reading off of this wire. Oh. Oh, I see why, I think. Because the other ground... Wait a minute. Yes, the other ground should be connected there. We can just connect it to here, I guess. Okay, that the negative ground from the other battery was not connected because they're actually separate. That's why I wasn't getting a reading. Okay, that's minus 13. So yeah, I get voltage there now. I am going to try to hook this back up here, because I would like to monitor something. Now, let's put this tape back on here. Alright, get all that stuff going on. We got a plus and minus supply. Minus goes to pin 4. I'm gonna need more wire. Plus goes to pin 7. We got resistor values. Typically I use orange for, let's see, negative. But didn't I just cut that up? That. Okay. So what I'm going to do is pin 4. So what I'll do is I'll just put the wire there to get ready to power up. Actually, what I could do, maybe nice to have a switch to turn things on and off, you know. And the other one is plus goes to pin 7. So I'll grab a red wire for that somewhere. There are some interesting little pre-tests that we're going to do, but that should work with this amplifier circuit. Alright, so positive is here. Let's see, this is... Why is that going? That's going to ground. That's my common ground. So now I've got my positive and negative ready for that. For the 386, positive goes to pin 6. And I'm just going to double check it over here. I've got positive on pin 6 and a 100 nanofarad. I got that on the positive rail, but I don't have it on the negative rail. I should probably put one in there, shouldn't I? Maybe we'll just leave it. I don't need that in there. Alright, let me do my input resistors. The input resistor goes to one end of this guy. This is ground. Why is this ground? Center tap goes to 2. One end goes to the end of that. That center tap goes to pin 3. And 5 goes to the speaker. And that's between 1 and 8. Another capacitor. That's a bypass capacitor that we added from the output to ground. And now we've got this resistor. There's a positive. Well, I could do pins 3 to ground. That's a 1K. That's easy to do. Let's see. Let me just double check something over here. Hello, hello, hello. Okay, so we're all good over there. The other end of this resistor, I've got it going to ground, but I don't think it goes to ground. I made a mistake here. This goes to the input of the signal source. I just put it there, I guess. I could put it here. That's the input to the signal source. That's a 1K resistor, which is good, which is here. And then we've got the small valued capacitor, which is somewhere. Now that's another 10K, isn't it? Or 10 microfarad. Why do I have 2 of these? I got the 10 from 1 to 8. What did I see that other 10 microfarad being used? They've got one between 2 and 7. 100 microfarad between 2 and 7. I don't even see pin 7 used on. Pin 7 is a bypass. It's not used in this circuit. Well, maybe that's where I was going to put that capacitor. The 100 microfarad. This is a 10 microfarad though. Radio waves. They just got a tuned circuit. Well, I don't know what they're doing there. The bypass capacitor is interesting. That's 100 microfarad. Oh, it says 47 to 100 microfarads. A bypass capacitor. (47 to 100 microfarads). See, that one's open. 47 to 100 microfarads. Well, there's 100 microfarad. That's from -2 to ground. No, between pins 2 and 7. 7 here is the power supply. Between the power supply and the negative input, they're showing here. I've got the minus input to ground. That's the 386. I don't know why they put that in there. Let's put in, we're going to put this bypass, it says 47 microfarads to 100 microfarad. I got 100 microfarad between 2 and 7. 2 is the input. 2 is connected to that part of the resistor, which is there, and the variable part is connected to that. This is the plus. Something's not right here. They're using the plus part on the 386 as the input. Oh, I see what I was doing. Okay, that's correct. That's pin 2. Pin 2 and 7. Pin 7. Pin 7. Pin 2 is the input. It's just pin 2 to the plus side. So that means the plus has to be on there, so that means the minus has to be on pin 2, which is here. And alright, so I've got a capacitor, and that's supposed to be pin 7. 5, 6, 7. Wait, is that on? Wait, I'm doing this wrong. I'm doing this wrong. Shit. I grabbed pin 2 of the 741. It's supposed to be pin 2 of the 386. And that's got a wire going there. So I could connect it to... That's going to be hard to get in there without short-circuiting something. I'll connect it. I can't reach that far. I'm going to need another wire. So I've got an attempted bypass capacitor. Wait a minute. That isn't right. Yes, it is. Pin 2. I can't get it in that freaking hole. That's a bypass capacitor. I'm going to need another wire. My wire's over there. So I'm doing all the pre-circuitry here before I haven't even got to the Raudive circuit yet, which really doesn't consist of that much. And that Raudive circuit, I mean, again, it's just like a crystal radio. I mean, it's just, you know, what are you gonna do, you know? I don't know. It's just, but once we get this built, there will be some considerable noise here. So I'm gonna grab the plus side here. We're going to hook up this bypass capacitor. I've got this, and I'm going to connect, well, now I've got to do there's the 1K, which, wait a minute, something's wrong. There's a 10K in there, I think. That's orange. I need a 1K. So we go from the end of this resistor. It's going to be a 1K right there. And then there's a 1 microfarad capacitor, which we don't have. We've got a 4.7. And there's the minus. And the plus goes towards the input, which is there. God, it takes so long to put this shit together, you know? It's like being a pain tonight. So we have our input capacitor set up. That's that resistor. That goes to pin 2. And the output of that resistor goes to there. Now 6 has to be connected to the connection of those two resistors as well. So I'll need a 1, 2, 3, 4, 5, 6. So I'm going to need a yellowish wire. Usually I use green for signal, but no, I don't have any yellow wire, do I? Huh. Well, actually I could use the speaker wire. Or I could use this green one. We'll use the green one. It's either green or yellow I use for signal. Usually it's green. I try to have some sort of convention, you know? So I want to go from pin 6, 1, 2, 3, 4, 5, 6, to the connection of both of those resistors. And that would be right there. Do have a little bit of cross connecting. Everything is, oh wait, now I need pin 3 on the 741 to ground with a 1K. Is this a 1 or a 10? What are they? That's a 10. I should have a 1K here somewhere. Right there. So I want pin 3 to ground. Everything is connected. I will connect up the audio amp first. 4 goes to ground. And pin 6 goes to positive. Let's see, 1, 2, 3, 4, 5. Wait, that's the output. 5 is the output, and 6 is there, so we should hear a noise now. I don't hear anything, actually. I'll have to turn off this heater because I don't hear anything coming. I should hear like I should hear something. Oh, you know what? The 386 is not grounded. That's why. That's why. So we just need another ground wire from somewhere. Here's this one. I am jumping over to the stream. I've noticed that, like, I have 0 people watching me. Because people don't give a shit about this stuff, and I can't blame them. But once we start getting... Come on, get off of there. Static electricity just connects everything. It just attacks everything here. I can hear better now. Alright, so the ground is pin 4. Wait a minute, I already got it grounded. That's pin 4. Maybe it's just because we don't have an input or something. I don't know. I need a bigger screwdriver to turn that screw. And I had one somewhere. Just put that in the middle. Well, let's hook up this op amp. Pin 4 goes to negative. 1, 2, 3, 4. It could be because the voltage is so low. The 386 takes a pretty hefty voltage. And I need another power supply wire, don't I? Well, I should have a red wire. Let's use this one. Plus goes to pin 7. Negative goes to pin 4. Plus goes to pin 7. Negative. Plus. And 5, 6, 7 is a green wire. Uh-oh. Uh-oh, something's wrong. 1, 2, 3, 4. 4 is negative. 2 is minus. That's the center tap. And 3 is plus. 3 goes to ground with a resistor. Where the hell is the positive? It's pin 7. Where's the output go? Pin 6. 5, 6. That's the orange wire. I have that connected. Pin 5, there's nothing connected. 7 is the supply. 5, 6, 7. We should be hearing some noise. We've got both chips are operating. That's grounded. That's grounded. Interesting. Well, I guess the only thing left to do is to hook up a signal to the input. And to do that, all we gotta do is we need a wire to ground. Like so. Here's our ground. So now we're test calibrating the amplifier circuit. And then we go from here. Don't you dare knock my shit over. I got something like on the edge of death over here. And I don't know why all this wire is messed up. Alright, that goes there. And I've got a very low input. We could crank up the scope to monitor the input signal. No, something's not right. Let's see, this guy. I just want to monitor the input. I don't need all of this extraneous stuff on here. There we go. Now, I've got to fix something, or else I'm going to have a disaster. God, I'm already having a fucking disaster here. These cables just don't want to stay where I want to keep them. Pardon my French. Sometimes things get unruly. I've got a connector here that doesn't want to work well. It's not staying put. I got a connector that could be shorting out something somewhere. Now, the amp's not working. I don't know why. So I should be getting a decent signal here. Let's see. Yeah, something's not right. That's, what is that voltage level? I should be hearing something. So in order to test that, we've got to do something different here. Yeah, go ahead, just fall on the floor and stay there because I don't need it anymore. Right, this is the scope. This is my input connector thing. I wonder if I can... I want to take this out. I'm going to try to hook this up into here. That stays in there better. And this connector, I should be able... No, that's the... I need to have this guy. Now we gotta troubleshoot a circuit and find out why we don't have a connection. So here's our ground. And here's an input. So you can see there's an input there. Where the hell did the signal go to? You are kidding me, right? Well, there's gotta be something here. Where the hell did it fucking go? Oh my fucking god, I swear to god. There's a DC signal there. That shouldn't be DC. There should not be a DC voltage there. Yeah, if there's a DC voltage there, it shouldn't be there. Why the hell is there a DC voltage there? It's because I don't know actually why there's a DC voltage on that input like that. 2 is connected to the op amp. I need the book again. God. I don't know what's going on. I got a DC voltage. What about pin 6? Let's see. Pin 6 of the op amp. 5. Oh, that's just not good at all. The 741 is... I don't think the 740... Well... 741 could be bad. Because I'm looking at the output and there's nothing there except for... Shit. There's a very high DC voltage on the output of the 741. Let's look at come on, why is it doing this? 5 volts. What the? That's 2 volts per division. It's reading a shitload of volts here. Like freaking, I don't know what, you know? It's not good. It's because of this input. Something ain't right. I don't know if I should pop another 741 in here. Let's take the 741 out. Oh, I see the minus and the negative on the output of the 741. But you know what? Just looking at, let's see. Maybe there's nothing wrong with it. I am going to connect the input to, maybe this bypass capacitor is screwing something up. Let's bypass this input section. No, I still don't have. Well, whoa. Why is it reading a minus voltage? There isn't even anything connected to that. Oh, that's AC. There's 500 millivolts right there. Alright, well, that looks good. Okay, that looks good. Maybe the 741 is something's wrong with it. But what I'm going to do, so I want to go to the input of that, or let's see, not the input. That's the center tap. The center tap goes to the center tap of the resistor. I did something wrong. Oh, that's pin 5. Oh, something's not right. That should be pin 6. It is pin 6. Center tap? One end of that wire is supposed to go to pin 6. This is green wire. I did something wrong. I don't know what this orange wire is doing. I want to pull this thing out. It's on pin 3 of the 386. Yeah, that's not right. Pin 3 of the 386 is the center tap. I gotta pull this out of there. That's the center tap, I think. That's pin 3. This is the connection from, let's see, 1, 2, pin 2. Everything is messed up here. No, that's pin 2. The other end of that resistor, one end goes to the input, the other end goes to the end of that resistor, which is there. And that same connection, and the other end's connected to ground. And that same connection is supposed to be connected to pin 6, which is this guy. So this is the input. Now, pin 5 is the, no, it's pin, oh god, I did something wrong. No, that's pin 6. Okay, and ground is pin 4. Pin 2 is connected to ground. That's connected there. Pin 4 is connected to ground. That's the bypass between 1 and 8. And the output's connected to pin 5. The plus side. Minus side goes to the speaker. And the other end of the speaker is connected to ground. Maybe this. So I'm going to connect this to the 386. The 386 is not working. None of these, either of these op amps is not working. Alright, I'm going to take out, this is the gain, this is the bypass. I'm taking out the bypass cap. Something's wrong with this 386. It's not overheating. Let's take a look at the output of the 386, which should be here. Wait, I don't want to do that. See, that was my my signal source. I wanted to look at the output with the scope. So right now it's about 2 divisions peak to peak. So now if I go over with the scope and look at the speaker, there's nothing there. It's possible that the 386 is not getting enough voltage. We could put a 9-volt battery in there. I gotta see what time it is. This is frustrating. This is really frustrating, you know what I mean? Wow, it's 2:30 in the morning. Fuck. God, I don't know. I don't have... I have a connector for that 9-volt battery. Fuck, I ain't got enough room for nothing here. There's one in there. Here's a box of goodies. I know I got 9-volt connectors. I got like one 9-volt connector somewhere. God knows where it is. I mean, I could take, I think I can, well, I can't do it with the little one. I don't know what to fucking do. I don't feel like pulling out that 15-volt supply. You know what I could do? I could use the combination. I could go across the... Can I do that? If I connect the minus 15-volt rail to, instead of the other one, I would have... That would work. Let's connect pin 4 to the minus volt rail. Now, I'm still not hearing nothing. I think something's wrong with the 386. That's the only one I got. And the 741 is not even working either. This is a sad day for me, I'm telling you. Let me pull a 741 out. I'm gonna put in, where's my freaking plus wire here? I just had it there. Alright. What is it? Pin 7? Come on, get in there. Oh my freaking god, tonight. I swear to God, this is not working out for me. Now I got it connected to pin 8. One, two, three, 4. Now where's the ground? Minus pin 4 goes to... I don't even have that connected. I'm gonna put this boy over here. There's a way you can zero that voltage on the output of the op amp. What is that? Pin 6, which is this guy. Let me go back over here again. Four, 5, 6. What the fuck? 5, 6. Now I'm gonna pull this guy out. And we'll put it in over here somewhere. Ooh. Now that's reading a minus voltage. And it's not even amplifying. If I look at the input, there's my input signal. And it's at a minus voltage too, isn't it? See, this should give me a gain. Am I missing something? Pin 3 to ground. I mean, pin 3 through the resistor to ground, 1K. And pin 2 goes to the center tap. And the other end goes to the 1K and the capacitor and there. Yeah, that 741's got to be blown. There's got to be something wrong with it. There has to be. I'm going to pull it out of there. I got another one here, I think. I have had problems with circuits, so... Oh god, I didn't connect it up right. Or did I? 6 is the output, so it's got to be over here. What did I do? Just mess up the pin? Where the hell's the other pin? Go in. That's pin 4, 3, 2, 5, 5, 6, and 7. Pin 8 has nothing connected to it. This is my input. And the output is pin 6. That's not working either. I wonder if it's because there's not enough voltage. I mean, if I take the negative out, it goes to 0. If I take the positive out, I wonder if that one's gone too. Alright, I'm going to disconnect this crap here. Not doing good tonight. Not doing good. Plus 6.5. Minus 6.5 volts on both sections. That's the input. Where does that other one go? That just goes to, oh, that's supposed to be tied to the output actually, pin 6. Hmm. 741s are not working. The 386 isn't working. Pin 6, pin 7. I wonder if those are the right freaking pin numbers. Pin 7, pin 6 is the output. Pin 5 is an offset null. Pin 3 is plus, pin 2 is minus. Pin 3 is plus, pin 2 is minus. I wonder if there's a voltage, a minimum voltage for this thing. Supply voltage, there is no minimum. Maximum is plus 18. Differential input's 30. This thing's quite a hefty little amplifier. Well, here it says minimum is plus minus 10. I'm only using plus or minus. So if I had a 9-volt resistor battery, shit. Nominal is 15 volts. I don't want to bring that, plug that other thing in. I don't know if I got any choice tonight, to be honest. I don't want to use, I've got a power supply, but I need a snack. I guess it's time to bring out the big boys. Time to bring out the big boys. No, 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 no. I'm not going to do it that way. This wire's long enough. I could probably stick the whole thing right in there. I got AC electricity next to the frickin' scope, and you get all kinds of interference going on. This is taking 10 times longer than I thought this was going to take. This is ridiculous. Alright. Now, we're going to have 15 volts attached to everything. I'll see if something blows up now. I ain't hearing nothing. Wait, this is positive? The green is ground. Oh, you know what? This is ground, but it wasn't grounded. Let me just measure my voltages. That's plus 15. Uh-oh. Minus 15. Why do I have from ground to there a voltage? What the fuck is going on? That's plus. The center ground is here. Well, I did have a wire connected to both of them. I'm not stupid. I had that orange wire connected. I just need to reconnect another wire from that ground to this ground. But why am I getting a voltage there? This is ground. I'm getting 13.5 volts. Oh, you know what it could be? Because one of the resistors goes to ground. It's a resistive. Wait a minute now. Something ain't right. Why do I have a voltage there? I've got from here. Wait, that's minus 15. Why is there 13 volts there? Well, let me ground that wire and see if that makes a difference. This is ground. If I smoke my supply, I'm gonna be pissed. And I know that's negative. I almost smoked it. Come on, what the fuck? Yep, something's smoking. God damn it. I don't know what the fuck I did wrong. I can smell it. Damn it. What the fuck? Ow! God damn, that fucker's hot. I think I blew up a 741. Hey, is anybody watching? Nope. God damn it. I don't know what the fuck is going on here. Unless if that 741... Well, that 741's gone now. You know? It's like, what the fuck? That fucker's hot. I mean, fucking burning hot. You could cook an egg on that son of a bitch. Like, what the hell, you know? I wasn't getting a voltage on my negative side. It was there before. Alright, good, I got it back. Jesus, that fucker heated up good. I could smell something. So I got 15 volts. But why in the hell? This is ground. That's ground. Oh, I still have... Wait a minute. See something here. I still have my LM386 connected. But it's not grounded yet. Where's that wire? Where the hell's the damn ground wire I just pulled out of there? This is not a day for me today doing this. I haven't even got the Raudive circuit built yet. It's only like 3 components and I can't get the damn audio amp to work. I know that's a ground wire. I had a gray wire. Here it is. Let's try this again. This is ground. And this is ground. Zero. Minus 15. Okay. Alright, now I've got 15 volts onto the LM386. Now what I just need to do if I can find the cable. If I can wrap that around there. Alright, this is ground, and the input wire is here, and that connects to the variable. Wait a minute, what the hell? It's supposed to be pin 6. Where's the input to the 386? It's supposed to be pin 3 is supposed to be connected to the center tap of that one. Oh, I see what I did. So this guy goes over here. And the center tap. Wait a minute. The center tap, that's that resistor. One end of that 10K is supposed to be going to the input. But it's going to a variable resistor. I can't, my head's not thinking anymore. Oh God, you know what? No, that's ground. No, that's supply. That's supply. I've got that connected to the supply. The other end of that variable resistor is connected to the supply. It's supposed to be connected to ground. Ground is down here. That's the center tap. That end goes to that resistor, and that's supposed to be connected to pin 6 as well, which is that green cable. So there's the input, but the input's got to go over to here. Now, let me grab another wire. I'm setting up like a test wire thing here. So this guy will connect to over here, and then I can connect the output. Oh, something's happening. Well, I've got an AC, but there's a large DC component, which makes sense because I'm looking at the input. Now, if I adjust this guy, that's doing absolutely nothing. This is ground. That's grounded. That's grounded. Ground. Now I got the input going right into the I am confused as hell. The input goes to one end of that resistor, and the other end is the orange cable. So I need to look at... What the hell? Oh my God, you know what? I had my ground line on the scope connected to the positive on the supply. adjust this. Okay, so there's some adjustment there. I got that working. Well, obviously. But now what I want to see is the output on the speaker. What is this cable? This one end of this cable is the brown one, is the ground. Oh my god. You know what? It was connected to the supply. The speaker was connected to the supply, not the ground. Oh, I just want to use some bad words right now. I really do. But oh, wait a minute. What am I doing? This is the input. I know I got a level because I already measured it. And I just want to measure the output. There's nothing there. Like the 386 is not working. There's a capacitor here. Let me try looking here. There's nothing there. That's on pin 4. Uh-oh. Oh god. What the fuck am I doing today? Pin 4 is supposed to be connected to ground. I have this connected wrong. I've got pin 5 connected to the supply, and that's supposed to be the output. Pin 4 is connected to ground. That's over here. I have that connected to ground. Pin 5 is the output. That's correct. And pin 6 is supply. Okay, I did have it connected right. I don't know if this other capacitor is causing an issue. They don't have that connected. Let's pull this out. Let's connect to... Well, let's turn it on again. Nothing. Not a damn thing. There's my input signal. And there's my output signal. There's nothing there. The 386 has got to be blown. Because I'm putting 15, that's ground, 4 is ground, 2 is ground, let me look at this thing again. Where's the 386? 2 is minus. That's what it says. 2 is minus. I don't know where I've got another 386 kicking around. It's got to be gone. Has to be. I got 15 volts sitting on that thing. Here they got 2 connected to ground through a resistor. I took the bypass capacitor out. What if I just connect 2? 2 is connected directly to ground. 4 is connected to ground. I think it's blown. That's what I think. Pin 3 is that. Pin 3 is the input, which is a small value. Actually, I wonder if I get another 386. I don't know if I do. Those are 741s up there, I think. This sucks, you know what? This just radically is, I'm just not happy right now. what we're gonna end up having to do is see if I can build a discrete amplifier. I'm just so fucking pissed right now. I got an FET. I don't think this is 741. I got two 741s on here. And the FET. The 386 I had on there is gone. Oh, wait a minute. What is this? That's a 3904. There's a 3906. This might be the bridge circuit that I built. This is an input. I don't know what that resistor is. I can't do this tonight. I just cannot do it. You know, I'm supposed to have a 386. I got something else. I'm about ready to fucking give it up tonight, I'm telling you. It's just not happening for me. So I got this thing here. It's a USB and UCA 202 USB to audio interface. Like I can connect this to the... You know, everything's gonna get bad. I'm gonna effing lose it tonight. I'm just not gonna deal with this. It's not happening. You would have thought that I had more 386s, you know what? I don't know what that is. That's a weird one. That's an IF amp. IF amp is for higher frequencies and such. There's the MF102. Oh my god, I found a brand new one. Okay, that's the last one I got left right there. MF102 is like a FET. And then the IF amp. I got too much stuff here. Everything's just gonna go all the freaking haywire up here. I got too much here and it just doesn't want to stay or nothing. Those are some chips. Wide supply voltage range, 4 volts to 12 volts. This thing ought to be able to handle 15 volts. Supply voltage 15 volts. there's the input. So if I pull that 386 and turn that power supply on, I just find it difficult to believe that the 386 is blown, you know. I'm not happy camper right now. I don't even know where this one came from. This is a Radio Shack deal. It's been around for a few years. So I know it's brand new. It looks like part of this is broken. Oh. Alright, now so pin 5 is the output? Yes. Alright, pin 5 is the output. Pin 6 is positive. 7 and 8 I'm not using. I'm not using 1. Pin 2 is grounded. Pin 3 is the center tap of the input source. And the input source goes from here, which is this other resistor, which is connected to a resistor to ground, and the other end is connected to nothing really, and pin 4 is connected to ground, and ground is connected to ground. We can only hope. And then that resistor is connected to ground. So let's fire it up. Let's look at the input again. This is over here. And right now, that's a fairly substantial input right there. That's, well, I don't know, it's a couple hundred millivolts or something. Now, if I take that signal and connect it directly to the speaker, somehow, there's a green one, I can't use that one. This is my minus. That's grounded. No, that's the supply. That's minus, and the green is ground. Where's the speaker wire? There's one. That's ground. There's a speaker wire. So if I take the input signal and bring it over, I don't know if you can hear it, but there's a tone there. Okay. Alright, that's connected right to the speaker. Oh, you know what? Well, that's, yeah. That's to prevent, well, anyway. There's that. Now that's the input. So now I'm going to look at the output. I'm going to put the output on the scope right at the speaker input here. And we'll crank this up down a little when it's on AC. And here we go. Nothing. Nothing. I don't know. I don't know why the 386 circuit's not working. I don't know if it's because of this bypass. I'm going to pull this out. Nothing. It's a brand new 386. I don't know. I'm going to look at the voltage when I turn this on and off. What the fuck am I doing? That's ground. Okay, and this one. Alright, I'm going to look at the voltage when I pop this thing on here. Alright, so there's 15 volts. And I do not have any amplification whatsoever. Let's look at pin 3. Pin 3 is the orange wire. Maybe the breadboard's messed up. You know, the breadboard could be bad. That's pin 3. Pin 2 is grounded. I wonder if the breadboard's bad. I got a brand new breadboard sitting over here. See? Something ain't right. You know, the 741 wasn't working. The 386 is not working. I haven't put stuff on this breadboard. Well, I did actually do the, other thing, didn't I? I don't know. I don't know. I don't know what's going on. Let me try something different. Let me look at... I'm going to have that ground connected there. I got 15 volts. It's on pin 6. Pin 5 is the output. Does the speaker... I wonder if the speaker's bad. Well, no, because I just put a sound in there, didn't I? We just connected a sound to it. So we know the speaker's good. All the wires are in there good. Let me look at, I mean, the voltage seems to be okay. That's ground, signal ground. Signal. I'm going to look at pin 5. There's pin 5. That's ground. Pin 5. There's no signal coming out of the amplifier. It's not amplifying at all. I don't know. The only thing I can think of doing is putting it on a new breadboard. I don't know what to do. I just gonna have to. I don't know. No, I don't have no effing clue what is going on, why it's not working. It's very upsetting right now. Just nothing's working on this breadboard or something. I don't know. So everything's coming off. I'm going to leave that 386 on this breadboard. I don't know if I can. You know, this looks like a brand new breadboard, but I mean, something did get burnt right there. I don't know. I don't know what to do. I've never seen a problem like this before. What the hell? Why is this on here? What's that metal thing for? That's supposed to go on the back of that. I don't know what this piece of metal is. Is this, I have no idea what this metal is. You could have it underneath to protect the board or something. I don't know. I mean, no clue. Alright. Ground. Where am I going to put my ground? I usually put it like... to keep things straight, I put a ground on a separate thing here. And that way I keep my plus and minus sorted. This is ridiculous, I swear. I just want to say all kinds of bad words, you know? Just really do. I cannot believe 2 LM386s are gone. I just don't believe it. I just do not believe it. It's pin 6. I'll just put the input. I'll use that brown wire That's on pin 3. Pin 4. Well, I don't have a ground, do I? So I have to... Well, I could use this minus. I could use that minus as a ground. Let's do that. I'm going to check that ground connection too. So 3 is my input, 2 goes to ground. 6 is a supply. We've got a big ass capacitor here. It goes from pin 5. The plus side goes there to pin 5, which is here. There's that. And the speaker, the yellow one goes to ground. No, I'm just dealing with a basic bare bones 386 here. I'm just trying to get something, a 386 working, you know? This is ridiculous. I shouldn't be spending 3 hours to make one chip work. Seriously, you know? Alright, the input is on pin 3. And I'm just going to hook it right to the input. There's a supply. There's this. It should work, right? The only thing I don't have connected is a bypass. Now I just need my input connected to a ground, which I'm going to check the voltage. Kind of need a wire over there, don't I? Just put that in like that. Very upsetting tonight. Just nothing's working right. It goes like that. So the first thing I'm going to do, get all this shit discombobulated. Freaking diodes are a little messed up. And we should have a better neater organizational area. Now, we ought to hear something here. Seriously, people. I want to check the voltage, and hopefully we get a sound. Nothing. We have voltage. There's my input signal. I don't know what frequency that is. 1 kilohertz. And wait a minute. That's actually not my monitored voltage. This is ground. And my monitored voltage is there. The 386 is not working. Or that circuit's not working. Or the speaker's loading it down or something. I don't know. What the hell is going on? Maybe it's just meant to be, you know? Maybe the signal input's not enough. I mean, I'm using a high output. You know what? No, there's something seriously wrong. with the circuit. I don't know what the hell is going on. I don't know. Two is ground, three is input, four is ground, six is supply. What if I pull out the speaker? I wonder if I pull the speaker off. Let's see. This is the... Wait, the speaker's not even connected. Where's the speaker? Yeah, it is. Alright, I disconnected the speaker. Let's see if we get an output here. Nothing. Oh, why is it doing that? Yeah, let's look at the input again. That's pin 6. Right? Wait a minute, that's the supply. What the hell? I need to be looking at pin 5 here. There's nothing. Right, this is not going to happen. Well, the 386 is not working. I gotta build an amp with a 2N222 or something. This is fucked up, I swear to God. That's plus. That's ground. I got 15 volts right on that chip. Why doesn't it work? Huh. I don't know. I am baffled. I'm just really baffled. I do not know why this chip is not working. The 741's not working. This chip is not working. I got 15 volts going in there. I got 6 volts. I can't do anything unless I have an audio amplifier of some sort. I have a mixer. Yeah, but I can't do that. It's got to be a transistorized amplifier. You know what? I'm gonna do it. To hell with it. It's almost 4 o'clock in the freaking morning. There's a 3904 right there, 5 volts, with an 8 ohm speaker. There's 12 volts on something. There's a 2N222. Microfarad. No, that's what I'm building. I'm giving up on this damn chip. The problem anyway is the fact that in the end I'm not using these chips anyway. But still, you know, I should be able to get the damn things to work. It's pissing me off. I wonder if I've got... There's a transistor there. What is this one? Oh, that's a 12 volt regulator. There's no transistors over there. God damn it. Fuck. PNP. I need an NPN. I probably didn't get... I know I bought some of the damn things. There's one. I want to try one of those. I want to try one of these things too. What the hell? I want to see something to work tonight after 4 fucking hours. Pardon my French, but I am really just losing it tonight. Now on these things, I don't know what the hell is what and where. I think the voltage is here and the ground is here, but the output I have no idea where it is. And I should try that with a battery to figure that out. Alright, well, and it's not going to tell me I think it's emitter base collector. I'm almost certain. I do know the base is in the middle. We're gonna build. There's a 10K and a 1K. I'll build that design. There's a 10. We need to have an amplifier. I cannot do anything without an amplifier. Alright, so the 10K, I should remove my... I'm not going to have time to mess with this other thing. So I don't know why this does not show up here. See, I'm building this circuit here, which in the end it's really a better circuit than the LM386, believe it or not. I should have just done it in the first place. So the 10K goes to the collector, which I believe is on the right, and that actually connects to the base. And then the base also connects to the emitter, which is the 1K. There's that. I think it's right. Is that orange? Oh my god, I can't see this. That's orange. God, I need a 1K. I need a red. That was a 10K I put in there. Where the hell did the other resistors go? You gotta be kidding me. This is not happening. I'll just rip one off that other board. I know I had 1K resistors here. You know what? I'm ripping one. I'm just really getting upset tonight. There's no reason why this LM386, I spent 3 or 4 hours on one stupid amp. I need a 10 microfarad. We could use a 4. I think I get a, do I have a 10? I think I have a 10. Right there. And the, well, the plus probably goes to the input, and that goes to the base. There's that. The 1K goes to ground. The emitter goes to ground. I shouldn't be using yellow. Base collector emitter. I mean, wait a minute, it's emitter base collector. So the emitter goes to ground. I should look that up. Well, let me... One, two, three. 1 is emitter, 2 is base, and 3 is collector. That's with the flat side pointing to you. So it's emitter base collector. I'm just so good. So now I need, so the emitter is 1K to ground, the emitter is to ground. Wait a minute. Emitter is 1K connected to the emitter. From emitter to base, that goes to ground. The speaker goes to ground. The speaker. It's one speaker wire. Ground. I want to try, what the hell is this? I want to try the battery first. So we're going to use this wire as our plus. Hopefully this wire is our negative, which is here. And these wires shouldn't be mixed up like this. It works, trust me. I don't know what that's doing there. We're gonna have an input cable. That's with the capacitor. And an input ground. There's my input. Wait, that's emitter. Okay, so I got that. The speaker, there's a 100 microfarad capacitor across the speaker to ground, and the plus is on the plus side. Put it there, like that. And the other end of the speaker goes to the capacitor. Oh, something's not right. What is the speaker connects to the collector, which emitter base collector. You could actually use a variable resistor in place of that. That will give us a little bit of level control. There's the speaker, the ground, and the supply goes to one end of the speaker. But how does it connect to the oh, it just goes through the speaker. The other, wait a minute, something ain't right here. The speaker does not go to ground. The speaker connects to the collector. I thought I just did that though. Uh-oh, I did something wrong. Here we go again. The capacitor goes across, goes to the supply. It just goes across the supply. And the speaker goes from the supply to the collector. Alright, so that's the supply lead. That's collector. Well, I have that connected to there. One end of the supply, and the other end of the speaker goes to So all I gotta do is connect up the supply now. I'm getting there. And I'll just take this out. Now the transistor is running. On 6 volts. And there's no sound coming out whatsoever. The base is the only thing connected to ground. The base? No, the collector is connected to ground. And the 1K resistor is connected to ground. I don't think something's right. The 1K resistor is connected to the base and the collector is connected to ground. And that's right, there's the base. The collector has the 10K. That's correct. The capacitor is connected to the base. There's the scope here. Oh. There's that. There's that. Well, it would help to have a signal. Alright, finally we got an amplifier. So you can see the inputs, can you see the, oh, alright, so, good, about freaking time, I swear to God, I swear I'm going crazy. So, you can't really see it that well, but we're going to measure the output level. The input level staying the same. So that's good. So there's no reflected impedance that we have to worry about. Now we're going to look at the output, which is going to be across the speaker. Well, there's one end of the speaker there. And the other end of the speaker is... God, I don't even know how to do this. It goes from there to the speaker. Where's the yellow? Here? That's the supply voltage. So there should be a capacitor on the supply voltage, because that means that the signal is going back into the supply, and you don't want that. So there's some pretty bad distortion there. And that's probably because the speaker is going back into the supply. So now again, if I look at the input, I've got 2 divisions peak to peak. And if I look at the output, which is connected, the other end of the speaker is connected right to the supply. I'm not even seeing a level there. Alright, something's wrong. I'm not measuring the right spot. I'm not measuring. I'm measuring from ground. And I need to measure from the speaker. So I've got, with a considerable amount of distortion, that's about 2 divisions peak to peak. And there's 4 divisions peak to peak. But I gotta, it's all distorted all to hell. Really, the way this should be connected, this isn't connected right. Whoever built that circuit on the thing's really messed up. There should be a resistor, like that should go to ground. Alright, so what we have to do here to fix this, and I'll bring up the thing here if I can. We're going to replace the, we're just going to remove the, we're going to remove the speaker altogether. And the capacitor across everything is fine, but we need another capacitor. I don't know what value that is. 10? Did they use 10? We'll use a 10. So that's the supply, that's the capacitor, that's ground. I'm not going to look at that. I need to go from the variable resistor to the capacitor. That's going to be the plus. And then the speaker is going to go from the output capacitor to ground. Uh-oh, it's not working. Is it plugged in? Shit. What's the fucking thing here? Tools peak to peak. Do I have, is my supply, my transistor supplied? Where's the voltage to the transistor? Has to go to the collector. So I don't have, I've got a series resistor to limit the current and a capacitor going to the, whatchamacallit, the speaker. So I just need another wire to go from, oh God, I need another wire to go from the supply to the collector. Now there's a sound there. Let's go ahead and do the retest. So we're going to look at the input again. Make sure that the input actually looks a little distorted, but anyway, it's not changing level. That's what we want to make sure, that there's no reflected impedance changes. And we're going to go from ground to the speaker. and there's a considerable loss. There's like no gain whatsoever. It's being clipped at the positive, on the positive voltage. It's being clipped for some reason. I wonder if this capacitor's got something to do with it. Well, the capacitor actually helped a little. Ow! God damn it, that fucker's hot. Oh, that's not good. Why is that so hot? That thing is really hot. That should not be hot like that. Wow. I didn't like burn myself or anything, but seriously. From base to emitter is 1K. I could look at that circuit again. Oh, I know why it's so hot. Because the emitter is connected directly to ground, and it's going right through the 8 ohm resistor. Well, I took that out, actually. Oh, yeah. Oh, I see what I... What the hell? This is a really bad circuit. Yeah, there needs to be like another 10K resistor in there. I don't know. I think I'm gonna have to call it quits or just stay up all night. Well, that circuit's really frigged up. I mean, seriously, what the hell? That circuit ain't no good. See, there's the circuit you want right there. You want a resistor, and there's some stuff going on down here for temperature compensation and all that crap. They got a 100 ohm resistor in there. A 33K resistor here. Let's try I've got 100. That's a 10K. I thought I had a 100K resistor somewhere. Let that fucker's cool down. It's 10K. Wait, I think it's 100K. And we're gonna use, that's 100 ohm. So I'm gonna run 100 ohm from the power supply to the collector. And then from, where's the speaker? The speaker will go not directly to, the speaker's connected. Yeah. So the variable resistor I want to go from here. There's the collector. And the emitter is connected to ground. that's a 1K there. We're going to change the 1K. That's base to emitter. Collector to base. Collector to base. We're going to take out this 10K. And we'll put in 100K. The 1K goes from emitter to base. I don't care about that. And then it uses 100 nanofarad. I don't care about that. And then it uses a 1 microfarad capacitor instead of, well, I got a 4 microfarad. It's really not a big deal. Now, when we fire this up, that thing shouldn't get as hot. I don't have any signal output at all. I'm checking the transistor. It's not hot as hell. And we've got .400 volts, 400 millivolts peak to peak on the input. I'm going to check my voltages now. So from base to emitter, we want to see a voltage drop. No, that's ground. There's 6.5 volts there. That's the collector. Oh shit, we know what I did. I connected the resistor from collector to collector. Really gotta have good eyesight to do this job, I'm telling you. Alright, let's fire this up again. Still nothing. Well, the transistor's not hot. Uh-oh. I've got a DC voltage on the output. Well, that's because I'm looking at the direct output here. It's getting distorted. Wait. That's only one division peak to peak. Our poor amplifier is not doing very well. That's 2 divisions peak to peak. Our amplifier is just pretty sad. Yep. It's sad. I don't know. I got a 100K resistor from base to collector. They've got a 33K resistor in there. If I change it back to a 10, which I could do, or I could even change it to a 1 for that matter. Let's change it to a 1. I think there's a 1 here. Well, what is this? That's a 1K. I want to try a 1K in there. So you gotta properly bias things. Whoa. It's just distorted. It's like turned it into a square wave for some reason, somehow. I'm not sure why. Damn it. That's the output with no resistances in there. It's pretty it's distorted pretty bad. Now if I use, it's amplifying, because I know the input's 2 divisions. Let me go back here. Oh, no, you wait now. So there's some reflected distortion in there somewhere. Okay, see the input is, well, I don't know. I mean, some of the distortion goes away. What is that? That's 1 volt peak to peak. Why don't we try cranking the voltage up? I mean, I can get a significant gain on the input, and there doesn't seem to be that much distortion. So I'm wondering about the output though. So the output's being limited. So it's actually overdriving the amp. The input level is overdriving the amp. Which I'm wondering. Let's see here. That's actually about 3 divisions peak to peak right there on the output. And on the input, without any distortion. Oh, we've got a gain. We do have a gain. We've got an amplifier. Oh, yeah! That's 1 division, peak to peak, undistorted on the input. And the output, oh, well, I guess I made a liar out of me. What did I do wrong? Something's wrong. I don't know what I did. Oh, okay. What did I do wrong? I had a gain and now I don't have a gain. What the hell is going on here? Yeah, I don't know. I thought I had a gain. I don't have a gain. Yes, I do. What is going on here? There's a gain. There is a gain. You wait just a minute now. That's 1 division peak to peak on 0.2. Oh yeah, there's a gain. I've got a ×3 amplifier right there. It's only a ×3. So what we really need is probably like we need to have a better output gain. You know, maybe we could run it into a 12 volt. I wonder if I changed the power supply. I wonder if I'd get another gain out of that. Let's try that. Let's try the other power supply. That's a 15 volt supply. The higher voltage should give us. Oh my fucking god, get in the amp. Alright, so this is the 15 volt supply. Uh-oh. What happened? What the fuck happened now? Wait. I'm not on the right line. So it's about the same, but you can see the ripple in the electric power supply now. It's bouncing back and well, you can't see it, but I can see it shifting back and forth. And there's no appreciable difference. So batteries are always better if you can use them. Fuck, where's everything? But we need more amplification than that, or it's just not gonna work. I gotta have at least like something. Now I wonder, just for kicks and grins, since it's so late, let's grab, I got one diode here that I know is 0.3, and what we're gonna do, rather than look at, we're looking at the output right now. So what I'm going to do, like if I grab that right there, if I do the diode, it's just a diode, a resistor, and a capacitor. Diode's connected to an antenna. No, I do have an antenna back there, buried amongst all this stuff. I'm just not happy tonight. This has been a very difficult night for me. Not working at all. I don't know if I can cut this up without breaking it or not. Yeah, I don't know. I need something. I have a radio coil antenna here that I dug out of an old radio. And we're just going to hook this up to the diode. And the diode is where? Right here. So the black part is the line. The antenna is a coil. So I don't know. That does go in there actually. We could connect the other part of the antenna to ground, I suppose. And the input to the diode. Now we'll look at the output on here. And that's at a real low value right there. Oh, I don't have... Yeah, the battery's all hooked up and everything. So there's like nothing there that you can see, obviously. We're down into the millivolts here, 10 millivolts peak to peak. I don't know if can I do free running? Normal. So, I mean, that's I would assume that's amplified. If I go to the input, That's actually even less of a signal, believe it or not. It's not even, it's not even triggering. What the hell is going on? Come on, damn it. I don't know what's going on with this now. I can't even get my signal. I don't know, the scope's dying or something. I don't know what the fuck's wrong with this. Damn fucking triggering's not working. I can't get it on that last setting. So there's noise there. Let me just go back here. Oh yeah, so there's actually, I mean, I can see that's like 0.1 divisions peak to peak with some stuff in there on the input. And if I go to the output, there is some noise there. That's actually 0.2 divisions peak to peak. So, I mean, I don't know. You know, use my body as an antenna. See, there's the input there. That noise. That's unrectified input right there. And that's probably picking up like hum noise and stuff. On the other side of the diode. Oh, look at that. What is that? See, there's some stuff in there. So that would be, you can't, well, you can't see it if the thing's in the way. So we've been just going over this. I'm just going to get rid of all of this stuff here. Why couldn't I fucking... I gotta do something. No, it's gone again. Yep. Fucking assholes. I'm talking about something else and doing something else and nothing works for me anymore. I'll solve that effing problem. Just wait. Anyway, on the scope, there is an increase in noise. I'm looking at the output. You really can't see it that well. I'll have to go back to the input where the diode is. This germanium diode. Well, that's not the input. It doesn't even show up. So you see the line is actually like brighter. You can't see it, but it's brighter, and it's like there's not, that noise is not there. So if I go to the output again, you can't hear it in the speaker because it's down into the really low millivolt range, 0.2 millivolts peak to peak. But there is, now if I go to the diode, you can see how touching that diode, there's some stuff there. There's some stuff going on there, but that's, now if I look at the input to the diode, get rid of this antenna thing because it ain't working. There's actually some pulses in there that's happening. They're probably 60-second pulses. Oh, there's some interesting stuff there. There's some other pulses in there. You know, and I'm using myself as an antenna. No. That's your 60 hertz hum in there and all this other crap. But we did get a ×3 gain in that amplifier. I think what it really needs is the FET preamp that I was using for the static stuff. So if we get the FET preamp, which is in that other circuit over there, and we get a ×3 gain here, we could, that went up to, what was that actually? That was 0.24, 600 millivolts peak to peak. That's actually high enough to run into the input mic of a computer. And there's no distortion at the lower level, like if it doesn't get oversaturated. I mean, ×3 is not a lot to speak of. And maybe I can work on the gain of this amplifier a little bit more, and then if we build an FET preamp, I don't know. So that goes in there. I'm done.